Hi, sorry I'm not there today. I meant to give you a warning last week and forgot. I will be there tomorrow to be able to answer any questions from today. So if someone is playing this video and it is going too fast, feel free to push pause and wait till you can get caught up. Just sorry that you're learning today's lesson in your brand new packet by this video. Now, this packet, in some years, I actually combine it with Unit 3, but this year I decided to go back to having them be two separate because that was one really long chapter. Um, so we are going to be solving in this packet, we're going to be solving the trigonomic equations. So today we're going to first talk about their inverses, but let's go back and think about what we did in Gateway 2. So in the first one here in the bell work, I know you can do this yourself, but you'd have to pause the video right now. So let's just do this together. So tangent theta equals square root of 3, and we're finding this on the interval of 0 to 2 pi. Well, tangent is positive in quadrant 1 and quadrant 3, and so it's square root of 3 over 1, opposite over adjacent, which means that hypotenuse is 2. That is telling us our reference angle is 60 or pi over 3. So we have pi over 3, and then we go one reference angle past pi, so we would have 4 pi over 3. Okay, so in the middle one, we want sine of negative 1 over square root of 2. Well, sine is negative in quadrants 3 and 4, and it is opposite over hypotenuse. Well, that tells us that one is 1, and that reference angle for both of those would be 45 degrees. So if we go over to pi, we go 1 past it, it would be 5 pi over 4. And we go almost all the way to 2 pi, but not quite, so it'd be 7 pi over 4. So theta equals those two angles if we are going in all four quadrants. Now, secant, which is the buddy to cosine. Cosine is a over h, or adjacent over h, so secant is hypotenuse over adjacent. Cosine is positive in quadrant 1 and 4, so we're saying that is the hypotenuse. Adjacent would be 1, so this should be square root of 3, telling us our reference angle is 60 degrees or pi over 3. So theta equals pi over 3 and 5 pi over 3 in quadrant 4. Now, Gateway 2 is finding all the angles that are in, or between, 0 and 2 pi. What we're doing today is we're going to talk about the inverse functions. And so in Algebra 2, you saw two major properties between functions and their inverses. So to find an inverse, you switch the x and y value. Just take that x, put it where y was, take the y, put it where x is, and then you resolve it for y from where you've just put it. The graphs are the reflections over the line y equals x. We saw in Unit 1 that our calculator only gives us one solution when we use the inverse function, and this is going to be y. Okay, so it's trying to give us an actual function where when we are looking at these angles here, if we're looking at the whole graph, it won't be a function if we're going between those x values. So we're going to start with sine. Here's a graph of sine, and if I am looking at this, I'm going to go ahead and kind of label my quadrants. This is quadrant 1 between 0 and 2 pi. This is quadrant 2 between pi over 2 and pi, and quadrant 3 between pi and 3 pi over 2, and quadrant 4 between 3 pi over 2 and 2 pi. Now going to the left, or going negative here, well, this is where it looks exact same as quadrant 4, so this would be then quadrant 3. Remember, with when we draw them like this, you just keep going around and around and around, right? Okay, so if we're looking at this, and I want to figure out where my inverse would be, okay? If I were to draw a horizontal line and it fails the horizontal line test, that means the inverse would not be a function. So like right here in quadrant 1 and 2, it would hit the function 2 times, okay? So that means if quadrant 1 and 2 are used, my inverse could not be a function, okay? Same thing as if I did quadrant 3 and 4, it would be the same thing. But if we look between quadrant 4 and quadrant 1, no horizontal line in between this would touch more than once. So this is the main part that we were going to use. Whoa, that just got really dark for some reason, sorry. For our inverse. Now, when you type sign in your calculator and you enter a positive or a negative, sign is positive and negative in both of those quadrants. And those are the two quadrants that the calculator will give you. It won't give you an angle in quadrant 2 or 3. Okay? So I'm going to write these points here. Oh, that's a highlighter, sorry. So this is 0, 0. This point up here is pi over 2, 1. This point right here is negative pi over 2, negative 1. Okay, so we can draw our inverse function if we go over to the box to the right. If we switch that number 1 up here, switch x and y values, okay? So for the pi over 2 comma 1, we'll switch those. So now we want 1 comma pi over 2. So you can see the x-axis there is already labeled. You can see the 2. So this is 1, this is negative 1, this is pi, and this is negative pi over 2, or positive pi. Oh my goodness, I'm just kind of not writing that correctly. This one's negative down here. There we go. So that's how all of these on the inverse ones are going to be labeled. I just couldn't put pi on the graph like I wanted to. So, all right, so I'm going to graph 1 comma pi over 2, and I get the point right here. So this is 1 pi over 2. 0, 0, switch x and y. Guess what? We get 0, 0. And then negative pi over 2 comma negative 1. We're going to switch those, and we get negative 1, negative pi over 2. Okay, and this will be our inverse. And the graph, oh, that was weird. Okay, hold on. It is kind of curved, because if you look, if I were to draw a line, y equals x. Oh, that did not go through those. Okay. So you can kind of see how it would kind of curve that way. This one would kind of curve that way. I should have done a different color. I'm going to erase the line itself. So you should see the green one should look like what we just drew. All right. So for the notations of the inverse, well, we've been using the ones in our calculator, right? We have sine has the negative 1 power of x. We also have sine, the inverse sine can be written as arc sine x. And then both of these are the same way if we are looking for inverse. It's the same thing as saying sine of y equals x. So the domain of the inverse will be how far left does this inverse go to how far right. So it goes to -1, and to the right it stops at +1. The range is -π/2 to +π/2. And the quadrants we know we will have the inverse in is 1 and 4. Now, again, this is so we are getting an actual function, okay? So now we go to inverse of cosine. So again, if I'm looking right here, because this one was, sine was 1 and 4, okay? Again, this is quadrant 1. Now we got quadrant 4, quadrant 3 over there. Okay. Quadrant 1 and 4 for cosine, it fails the horizontal line test. So that one does not work, okay? But you know in all of the functions, when you type them in your calculator, it will give you, if it's positive, it will give you an angle in quadrant 1, okay? So if we're using quadrant 1 and we want it to pass the horizontal line test, we can see that this one will include quadrant 2. Okay, so let's take those points. This one right here would be 0, 1. Then we have π/2, 0. And then we have pi, -1. So now we can graph our inverse by switching the x and y values. So I have 0, 1. So now I want 1, 0. Don't forget, this is π/2 and this is pi. Okay. Then we have the point π/2, 0. So now we want 0 π/2. And we have pi, -1. Switch those. We want -1 pi. And again, it will be curved. See if I can do it correctly here. Oh, nope, it wants to draw a straight line. Here we go. Whee! You like my sound effect? It didn't work. It didn't make it smoother. All right, so that's what it should look like, kind of, if I drew it better. All right, so the notation for this would be y would equal the cosine with the -1 power, or arc cosine. And again, these are the same thing as saying cosine y equals x. Okay, our domain of the inverse is going from -1 to 1. Our range is going from 0 to pi. And the quadrants are quadrant 1 and 2. Okay. Now, once we talk about tangent, you'll kind of see why cosine is different than sine and tangent. So I'll talk about that here in just a second. But for tangent, if you're looking at this and you know you have asymptotes, okay? I don't know about you, but I look at one curve as what we would want to use instead of jumping from one curve and jumping over to the other curve, okay? So if we do that, this one would be quadrant 4 and quadrant 1. Right? Quadrant 2 starts on a different tangent curve in the function. okay? And so when we think about that, the reason cosine is the one that is different is because it is positive in both quadrant 1 and 4. So that would make it not use a negative. And so that's why it's a little different. All right. So there's a couple things we need to graph here besides just the points. We have points. We can state a point here. We have negative pi over 4 comma negative 1, 0, 0, pi over 4 comma 1. But we also have the asymptotes, right? We have an asymptote at x equals negative pi over 2. And this one would be x equals pi over 2. So when we are graphing the inverse, instead of saying x, we would say y. So y would equal, we have negative pi over 2, negative pi, pi over 2, and pi. Okay, so if y equals negative pi over 2 would be an asymptote, and so would pi over 2. Then we switch our points. So instead of negative pi over 4 comma negative 1, we go negative 1, negative pi over 4, 0, 0. And then we switch the pi over 4 comma 1 to 1 comma pi over 4. And then we can draw our curve. Okay. So the notation for this one is very, very similar to the others. Y would equal tangent to negative first power times x, or y would equal the arc tan of x. And again, this is tangent y would equal x. Okay. So let's talk about domain, range, and the quadrants here. So looking at the inverse graph, domain, how far left to how far right? Well, it's going forever both ways, so negative infinity to infinity. The range, notice it's approaching asymptotes, which means it doesn't have brackets like the sine and cosine did, but it goes the farthest low it is approaching is negative pi over 2, and the y value that it's approaching going up would be pi over 2. And again, this one is in quadrants 1 and 4. Now, I did include on here some, the sine, cosine, and tangents buddies, right? The cosecant, secant, and cotangent. So you can kind of see where those ones are at and what their inverse graph looks like. But this is just kind of here to help you. One of the things, though, I think you might like is when we're trying to graph. So if you are given a cosecant, you want the inverse of cosecant, and you're going to use your calculator, okay? This is how you would type it in. Because sine is x over 1, and so that means cosecant would be the 1 over x, right? But now if you're going to switch it backwards, so you have cosecant is the x, and sine is 1 over x, right? So this is kind of showing you a little bit backwards, but it's just whatever you get for cosecant, sine, or cotangent. Cosecant, secant, or tangent, cotangent. To push the buttons in your calculator to do that, you have to use sine, cosine, and tangent. But what's in the parentheses, will be 1 over that for what is with those trig functions. So the first ones we're going to do is without the calculator. So we are going to kind of support these with sketches because you know how much I like you showing as much work as you can. But I am going to write this a little bit different because when we were writing in those boxes and we had cosine to negative 1 or arc cosine, that it equaled cosine of y, well, in this case, it's our angle, would be the x. So I'm just kind of rewriting it. So arc cosine of 1/2 really is equaling theta, but we want theta. So remember, cosine is using quadrant 1 and 2. So when I draw this, 1/2 is positive, so that is in quadrant 1 and 4. But again, your calculator is not going to give you quadrant 4. It will always give you quadrant 1 if it's a positive number. So this would be where we're going to put our angle here. So we have cosine theta is 1/2. That is adjacent over hypotenuse, which means this side is square root of 3. Should kind of give you what your theta is. That should be 60 degrees, but we write everything as radians. So it's pi over 3. And that's a weird pi there, okay? So arc sine would be the same thing as saying sine theta equals -1 over square root of 2, which is how Gateway 2 looked, except this is not asking for all the angles between 0 and 2 pi. Okay, that's the difference. If the directions do not say between 0 and 2 pi, you're finding one answer, not both, or not, multiple. So sine, or arc sine, sorry, is in quadrant 1 and 4. I don't know what that wrote there. Okay, but this is sine theta is equaling a negative. Well, sine is negative in quadrants 3 and 4. The calculator will not give you 3 because quadrant 4 is closer to our starting, where we always start, the initial side of our angles. So the positive x-axis. So here would be our triangle. Sine is opposite, so that's -1 over hypotenuse, square root of 2. So that means this one's also 1. So this is a 45-degree reference angle. And if you were to put this in your calculator gives it to you as a negative number. So this is negative, and 45 degrees is, whoops, I forgot the negative there, is pi over 4. So just write it as negative pi over 4. Yes, it is 7 pi over 4 if you write it positive, but we're just finding basically the answer the calculator gives you. I would still accept 7 pi over 4, but right now we're not talking about that interval between 0 and 2 pi, which were all positive angles. Now you can even give negatives because I'm not giving you the interval to find the angle through, okay? So tangent, or inverse tangent of 0. So tangent theta equals 0. Okay, well, tangent is in quadrant 1 and 4. Tangent is 0. If you remember, tangent was the same thing as saying y over x, or sine over cosine. And if we're on an axis, it is y is 1 or -1 if we're going up or down. And it's 0 on the x-axis when x is 1 or -1. And so it has to be y over x. So we need y to be 0. So that means we'll be x being -1 and 1. But we only want the one closest to our initial side, or the positive x-axis, which would be the axis right between quadrant 1 and 4. Okay, and so what is that angle? Well, that angle is 0. Okay, so if I write cosecant inverse like cosecant theta would equal -2, but that's not how we put it in your calculator. We're going to change it to sine theta would equal 1 over -2, or -1/2. Okay, so if I draw let's see, sine, we are using quadrant 1 and 4, but sine is negative in quadrant 3 and 4, so we're not using the 1 in quadrant 3. Sine would be negative 1 over 2, which means this one is now square root of 3, which tells us that is a 30-degree reference angle, but it's negative because it went below 0, so it's negative pi over 6. Okay, now we're going to find arc secant. Now, like that one, I just changed it at the end there to sine. You could change it to arc cosine right here, and it'd be square root of 3 over 2. So you are finding theta if cosine theta equals square root of 3 over 2. Well, cosine is positive in quadrants 1 and 4. Well, the calculator is not going to give you quadrant 4. It will automatically give you quadrant 1 when they're positive. And so this is also cosine, so that's always dealing with quadrant 1 and 2. But we'll stick with just quadrant 1 because we're finding what the calculator will give you there. Okay, so that gives you the adjacent is square root of 3, the hypotenuse is 2, the opposite is 1. Okay, that tells you your reference angle here is 30 degrees, that 30, 60, 90 triangle. So theta here is pi over 6. Okay, so I could just change this to tangent here or tangent after rewriting. So let's see, tangent inverse, well, negative 1 reciprocal is negative 1. So we want to find tangent theta, we want that theta if it equals negative 1. Well, tangent is negative in quadrants 1 and 4. The calculator will give you quadrant 4, and it will give you this angle as a negative, but let's figure out what that angle is. Remember, tangent is opposite over adjacent, so that'd be a negative 1 over 1. This is square root of 2. That's a 45-degree reference angle, so our angle will be negative pi over 4. All right, so now we are going to deal with the calculator for the rest of these. Excuse me. Okay, so it wants you to give the answers in radians and degrees. So you have to make sure your mode is set correctly. So if I find the radians all first, I'll just leave it in that mode. Then if I switch it to degrees and I want to come back and do the inverse of cosine, I can just scroll up once I've changed the mode to degrees, scroll up till I get to that again and just push enter, and it'll give me it in degrees. So I'm going to do radians first. So the inverse cosine of negative 3 over 8. I hope you are doing this and having your calculator. If nothing else, the video is going to give you the answers, but make sure you're getting them in your calculator. So in radians, I got 1.955. Now, if you change your mode, you scroll up and put that answer again. I'm going to write the degrees here. You would get 112 degrees, 0.025. I guess I should say 112.024 degrees. All right, and so radians of the inverse of sine of negative 0.6 is negative 0.644. Make sure you're getting that, making sure you're rounding correctly. Give me 3 decimal places. If it doesn't round, sometimes that one rounds to 0, so then you only give me 2 decimal places. But now if I change it to degrees, you should get negative 36.87 degrees. And then arc cosecant, you need to remember we want to change this a little bit. Cosecant's buddy would be sine, so we're actually finding arc sine of 1 over 3.7. we had to take the reciprocal of that. So just make that its own little fraction there. So if I find the radians of that, I get 0.274. If I find it in degrees, I get 15.68 degrees. Okay, so make sure you are getting that. Make sure you remember how to enter that in your calculator. And you have page 4 to do today for your practice. I will take some questions tomorrow, so if you have them, keep track, and we will talk about it when I get back tomorrow. And I hope you guys all have a great rest of your day. See you tomorrow.